The other day, I had a discussion with a friend about the French virologist Luc Montagnier, who became famous for discovering the HIV virus that causes AIDS, and in fact, the connection between HIV and AIDS. He won a Nobel Prize for his work a few years ago, very rightly so. So, when I was discussing with my friend about the career and life of Montagnier, we obviously talked about all the great discoveries he made in the field of virology. But then we also ended up talking about some of the not so great speculations that he had about science in the last couple of years of his life. For instance, he was an advocate of electromagnetic signals from DNA, which also led to an advocacy of homeopathy. And especially in the last few years, in the last 2 years after the COVID pandemic started, he went on record and said that COVID was in fact a man-made virus, and it might have been the result of scientists trying to discover a vaccine for AIDS, and it might have been an accidental byproduct of this process. So Montagnier's example leads to an interesting question, and that question is simply: should scientists be allowed to speculate, and should scientific speculation by famous scientists be taken seriously? And the first reaction might be to dismiss this speculation as something outrageous, something that's unworthy of a serious scientist's business. But I think the answer is much more interesting. If you look at the history of science, there hasn't been any dearth of speculation among scientists. In fact, just in the 20th century, there's been quite a few scientists who have speculated, often to the detriment of their careers. Uh, Two examples of scientists who actually speculated on life outside planet Earth were Fred Hoyle and Francis Crick. And both of them, in fact, espoused the theory of panspermia, which says that life did not arise on Earth, but it was in fact brought to the Earth by some form of alien vehicle or alien process that we don't know. It kind of fell from the sky symbolically, so to speak. There's other people who have also speculated. Another famous example is the physicist Brian Josephson, who won a Nobel Prize for very important work he did in superconductivity when he was a graduate student. But right after he won the Nobel Prize, he kind of turned his attention to parapsychology and telepathy and psychokinesis and those kinds of things. Uh, Josephson has been derided by the scientific community for years, but he has clung to what he thinks are very reasonable speculations. Another example is, one of my favorite scientists who also happens to be a friend and mentor of mine, Freeman Dyson, who did a lot of spectacular science all his life. But he also was not averse to speculation. And in fact, in one of the reviews he wrote of a book for the New York Review of Books, he also speculated that parapsychological phenomena might in fact be real. So, what do you make of all of this? Is this something that should be supported? Is this something that should be discouraged? Well, certainly in their lives, people like Fred Hoyle and Freeman Dyson and Brian Josephson have been derided, mocked, sometimes even declared as outcasts by the scientific community for speculating in realms that are not supported by the evidence and way beyond the evidence. But it would be premature, I think, to dismiss the role of speculation in science. And the reason for this is very simple. The reason is simply that science deals with extremely complex phenomena. Even something as simple as an electron takes years to understand. It takes years to unravel the complex physics behind the electron using a lot of complicated mathematics. So, in general, it's very difficult for an individual or even for a group of individuals to really figure out what's going on with the universe or with nature, even when we are dealing with simple entities like electrons, let alone more complicated entities like a songbird, a redwood tree, a human baby, or certainly the human mind. And so, what you need when you're dealing with very complex problems like this is what we call a lot of shots on goal. So you need to come up with a lot of ideas that could potentially explain the structure of the universe and the structure of nature and life and so on. And so naturally, some of these ideas are going to be wrong. Some of these ideas are going to be very, very speculative. In fact, if you look at the history of science in the 18th and 19th century, you saw people speculate about all kinds of things. Uh, Bruno, who was burnt at the stake even way before that, speculated about life on other planets. John Mitchell, who was a Cambridge Don, speculated about black holes in the 17th or 18th century. And there's scores of examples of famous scientists speculating about things just because the phenomena they were studying were too complex to be figured out by the straight application of rational thinking. So the line between creative thinking in science and speculative thinking is in fact quite thin, and it's very easy to cross that line. Not just that, but crossing that line should be encouraged, because if you don't think speculatively at all, then you're only going to stick to what you already know. So in order to get creative thinking, you need to be okay with speculative thinking. And in fact, you need to encourage speculation. So I see absolutely nothing wrong in people like Montagnier and Josephson and Dyson and Crick and Hoyle and so on speculating. They can speculate all they want, because speculation is a very healthy part of science. And I think it's a very serious mistake for the conventional scientific community to deride them, to mock them, or to consider them unworthy of serious science. First of all these scientists who I talked about, they're highly accomplished scientists. A lot of them have done Nobel caliber work in their respective fields. So they certainly know what the scientific method is like. They're certainly not some kind of crazy people who have no idea how science works. What is interesting is that in spite of really appreciating how science works, and in spite of making foundational contributions to science, they still choose to speculate. So they know very well that they're crossing the boundary from the known into the unknown based on very sparse evidence. Another reason why they speculate is because they know, just like the great scientist and humanist Jacob Bronowski once said, that science intrinsically deals with the unknown. And in fact, the frontiers of science always deal with the unknown. And when you're dealing with the unknown, that means that you never have enough data. You never have enough evidence. You must think beyond the evidence. You must stick your neck out. You must take risks. A lot of your ideas will probably turn out to be wrong, but they are absolutely worth the price that you can pay for one or two ideas, not just being right, but potentially being revolutionary. And that's why speculation becomes very important, because it can lead you to one or two of those ideas that in fact turn out to be very important. So my general sense about speculation in science is that it should always be welcome, with one exception. And I think that's where it gets tricky. People like Luc Montagnier speculated about COVID being a man-made virus. More seriously, Kary Mullis, a biochemist who won the Nobel Prize for his invention of the polymerase chain reaction, one of the most important techniques in the history of biology, became both a climate change denier and a denier of the fact that HIV causes AIDS, which is kind of ironic since we started talking about Montagnier, who discovered the connection between HIV and AIDS. And I think it's in cases like that that speculation now becomes very dangerous, especially when it comes from famous scientists who are public names, because you don't want the public to take climate change denial seriously. You don't want them to start questioning that HIV actually causes AIDS, because in that case, it can be literally a life and death matter. So I think that's where I draw the line. When famous scientists start speculating about things that can actively harm the public, I think that's when they need to step back and do some serious thinking about what they're actually saying. But of course, even that line can be thin. I mean, you can also see parapsychology, for instance, which is seemingly harmless, being misinterpreted by the public and being taken up by charlatans who want to milk people for their gullibility. And so you can't really stop the public from misinterpreting speculation or taking advantage of it to try to swindle other people completely. That comes with the baggage. But I think there's a line beyond which it is, in fact, quite dangerous to speculate. But as far as I'm concerned, that line lies far beyond what a lot of other scientists might consider it to be, because I actually think that unless you speculate, you're not going to do creative, important science. Unless you speculate, you're not going to be able to explore the edge of the unknown. And unless you speculate, you won't bring about scientific revolutions.